Welcome students. Today we learn about force and its applications. It is very useful for your ICSE and CBSE exam. Now we can say or tell that what is force. What is force? From Newton's first law, we seen that a body remains in state of rest or in uniform motion, otherwise an external force is applied on it. So, force is the reason to change the state of a body from rest to motion. Suppose the body A is at rest and a force F is applied on it. The initial velocity of it is 0, but when a force F applied on it, it goes with a velocity 2 meter per second. So, force is responsible for change the state of an object. If it was rest, it will go with some velocity or acceleration, or if it is uniform, or the reverse phenomena will occur when it moves with some velocity. When it moves with some velocity, suppose u equal to 10 meter per second. Meter per second is the unit of velocity. Then if we apply some force opposite it, then it becomes 0. So, the force is the reason to change the state of a particle or object. Or we change the shape of an object. We change the shape of an object by applying force on it. Suppose we take an eraser and we push it by our finger, then its shape will be changed. So, force is responsible to change the shape and size of object. Force is responsible to change the shape and size of the object, and force is also responsible to change the state, whether it is rest or in uniform motion. Then we can apply force on it, then the rest particle will be moved with uniform velocity or acceleration, or the uniformly accelerated particle by uniformly motion particles will be rest after applying force on it. Now, force is a vector quantity. Force is vector quantity. Its unit in CGS system is, in CGS system the unit of force is dyn. It is written as dyn, and in SI unit, SI means system of international unit. SI means system of international unit. It is the extended version of MKS. In MKS system, we can get 3 physical quantity: length, mass and time, and another 4 quantities, that is current, substances, that is mole, temperature and intensity of light, candela, is added to MK system and it becomes SI system. In SI system, the unit of force is Newton, according to Sir Isaac Newton name. And there is also a unit, gravitational unit, but it is not so used in present days, that is kilogram. In SI system, kilogram force, and in CGS system, gram force. 1 kilogram force equal to 9.8 Newton and 1 gram force equal to 980 dyne. This is the unit of force in CGS system, SI system and in gravitational unit. Now, how do we measure force? How do we measure force? Now, there is 3 laws of motions of Newton's. There is 3 laws of motion. First is state about the definition of force, that is the reason to change or tend to change the state of object. That is, if we apply force on a state on a rest particle, it becomes moved with some velocity, or if we apply force in a particle already in motion, it comes to rest. So, the second laws of motion of Newton's state, the direction of force or the magnitude of force. It says that the rate of change of momentum is directly proportional to the applied force, and the change of momentum occurs in the direction of applied force. That is, F is proportional to rate of change of momentum dp dt. Now, you do not know ddt. What is ddt? It is a small change in a small time interval. Momentum is a vector quantity. It is defined by mass into velocity of any particle. If the mass of particle is 10 kg and velocity in SI system is 2 meter per second, that is linear momentum is 10 into 2, that is 20 kilogram meter per second. This is known as momentum. Now, if a particle have momentum at t1 second is suppose 10 kg meter second, and in t2 time the momentum is 30 kg meter second. Therefore, the change in momentum in between this time is given by 30 minus 10 kilogram meter second divided by time interval, that is t2 minus t1. If this quantity is very small, this is we get, if this is P2 and this is P1, then P2 minus P1 by T2 minus T1 is the rate of change of momentum. P2 minus P1 by T2 minus T1 is the rate of change of momentum. But if the momentum change occur is very small, then we can write the change of momentum is written as dp and change of time is dt. Actually, it is written as del p del t, and if the time is very small, then it is written as delta p by delta t for very small change of momentum with time. If this time interval, that is the change of momentum, takes place in which time is very small, it is written as delta t tends to 0. Then delta 2 tends to 0, del P del T means dP dt. But you don't worry, it is not the any cause of concern. You can easily do numericals. If you don't understand this, don't panic. You can do numericals easily. Then P equal to mv. F is proportional to ddt of mv. If mass is constant, mass is always constant, we know that mass is always constant. The mass of the particle is the amount of substances already exist in a particle or any object is called as mass, and it is constant in earth and outside the universe, that is like in moon, in sun, or outside the galaxy, the mass is always constant. So the constant term is always outside of this derivative. If we take the time derivative, that is ddt of 2 equal to 0, because the value of 2 does not change with time. 2 remains 2 in time. 2 is a number, that is it is a constant. If we take derivative of 2, that is if we take the change of the value of 2 with time, it is 0, because 2 does not change with time, it is a numerical. So ddt of mv, f is proportional to ddt of mv, m is coming outside the derivative and it is written as dv dt. Now dv dt is change of velocity with time. We know change of velocity with time is given by acceleration. F is equal to acceleration. I put an arrow. This arrow is a symbol of vector quantity. We know that force and acceleration both are vector quantity because it has both magnitude and direction. So it is written as F equal to ma. M is a scalar quantity. So from second law of motions, we find out the magnitude or value of force, that is force equal to, we can get force is equal to mass time acceleration. Now in numericals we have to find out this acceleration. The acceleration is not given in all maths, we have to find out it. In this case we have to use some equations. In which equations? Sorry. The equations of motions are S is equal to Vt, V equal to U plus At, S equal to Ut plus half of At square, and the charm for is V square is equal to U square plus 2 As. This 4 equation is needed to find out the acceleration. If here in this case the acceleration is 0, if a particle goes with uniform velocity, that is velocity does not change with time, then we can only use these equations. Otherwise we cannot take S equal to Vt. If acceleration is given, we find out S, that is S is the total displacement. S equal to total displacement. A equal to acceleration. V equal to final velocity. Acceleration means change in velocity. So there will be two defined velocity, one is initial, one is final. V equal to final velocity, U equal to initial velocity. And T equal to total time. Please write down these 4 equations, we can use it to solve numericals. Now there are two types of force. nature of force. One is contact force, and otherwise is contactless force, that is in contact force, non-contact force, non-contact force. At first we talk about contact force. Contact force means in which the force is physically applied to the body. Suppose we push a trunk horizontally, it is taken as ground. If a trunk is, this is trunk, if a trunk is placed on a ground and then put horizontally a force F on it, it goes with velocity v. So this type of force is physically applied to the body. This is an example of contact force. Another type of force is normal reaction force. If a body is placed on ground, it always put a force due to its weight mg. G is acceleration of gravity. Is always put a force due to its weight and downward direction. So the ground or floor, according to Newton's first law, there is an equal and opposite reaction to Fg force. So according to Newton's laws of motions, the floor is also given an equal force. If this is F1, then floor also gives an equal force to the body A in opposite direction. This force is called normal reaction. It is acted normally, but the line of action is different. This force direction is downward and normal action direction is upward. Force is normal reaction. This is also a contact force. Another example of contact force is tension of string. Tension of string. If a body is suspended from a rigid support with a string, then the force due to gravity acts along this direction, downward direction is mg. To hold the body A in equilibrium, that is, it does not fall down, an equal and opposite force or sometimes greater force is applied, which is called T, the tension of string, opposite to the weight of A, and it always directed away from the body. That is, the direction of weight is along downward direction and the direction of the tension of string is along this direction. If the body is in equilibrium, that is, it does not move, then T equal to obviously mg. And if this is goes downward direction, then mg is greater, mg minus T. This is the resultant of F. We know F equal to ma, then mg minus T equal to ma if we accelerate it. But here we can take it later. Here is tension of string is always a contact force. And another force is given, which is string force, which is force of spring. If two bodies are attached with this spring and these two bodies applied force on string along this direction, the spring is wants to compressed. but the spring always want to retain its original size. So it exert an equal and opposite force, which is called restoring force or reaction force, to regain its size. So for compressed, the spring exert equal force in opposite direction to the applied force to retain its original site. So if A and B, the force of A and B along this direction, so spring wants to eliminate this force or oppose this force in opposite direction to retain its original size. But if the spring is stretched, then the spring wants to retain its original size, that is, then is restoring force along this direction. So spring always opposes the external force. It always applies a force opposite to the external force, that is along opposite to its stretched or compressed. Compression or elongations. So this is always a contact force because all the forces are physically contacted. There is another force in nature which is not contact force. These forces are called non-contact force. কিছু কিছু ফোর্স আছে যেগুলো কন্ট্যাক্ট বুঝতে আমরা পারি না। নম্বর ওয়ান ইজ ফোর্স ইজ গ্র্যাভিটেশনাল ফোর্স। Number two is electrostatic force. Number three is magnetic force. And so on. Gravitational force is F equal to G m1 m2 divided by r square. If two masses m1 and m2 are situated at a distance r between them, if m1 and m2, two masses are situated at a distance r between them, then gravitational force is proportional to the product of their masses and inversely proportional to the square of their distance. But this is not contact force. We cannot contact with gravitational force, but this is a non-contact force. Electric force is similar to gravitational. Here mass are related and here charge is related, but the q1 q2 divided by r square. Here the constant use is g, here the constant use is k. G is universal gravitational constant and k is a constant which is equal to permittivity of free space. But there is many 90% similar of these two force, but gravitational force is always attractive force, but electric force or magnetic force, these two forces are attractive or repulsive. We know like poles are repel each other and opposite poles are attract each other. So it can be repulsive or attractive. Similar electrostatic and magnetic force, but gravitational force are always attractive in nature. This is the basic theory of force. I hope you understand it easily. So we get 1 Newton equal to key, we get F equal to ma. That is 1 Newton equal to 1 kg into 1 meter second to the power minus 2 or meter per second square. Now 1 kg equal to 1000 gram, 1 meter equal to 100 semi second minus 2, that is 10 to 1 2 3 4 5 gram semi second minus 2. What is gram second is 10 minus 2? Dyne. That is 10 to the power 5 dyne. 1 Newton equal to 10 to the power 5 dyne. This is very, you can say, very useful for unit conversion. And we do some numericals now. For numericals, we have to consider or remember 3 things in our mind. First is write down the quantities, that is M, A. Second, convert unit in one system. And number 3, do sum. This is the basic of doing numericals. Now we go to the example. How much acceleration will produced in a body of mass 10 kg acted upon by a force 2 kgf? How much acceleration is produced? How much acceleration is produced of body of mass 10 kg, given mass is 10 kg and force is 2 kgf, 2 kilogram force. Find out the acceleration. We can easily solve it. We know F equal to ma. At first convert kgf to Newton. We can know that 1 kgf equal to 9.8 Newton. Therefore 2 kgf equal to 2 into 9.8 Newton. That is 19.6 Newton. Now put F equal to ma formula. We can A equal to force divided by mass, that is 19.6 divided by 10, that is 1.96. If this is in SI unit, so the unit is meter second minus 2. Very easy. Now we go with the another example. Now we can do the second one. A lead bullet of mass 20 gram, travelling with a velocity 350 meter per second. A bullet of mass 20 gram accelerate with a velocity 350 meter second inverse. Come to rest. V equal to 0. Here u equal to initial velocity is 350 meter per second, and as it come to rest, the final velocity is 0. After penetrating in a steel target 40 semi, it penetrate into a steel target. If this is an steel target, it penetrate into the steel target. This is a steel target. It penetrate 40 semi. Find the resistive force offered by the target and the retardation caused by it. Find out the resistive force. As the bullet enters into this, it apply a resistive force equal and opposite to the external force of bullet. Opposite to the force of bullet, the steel target gives a retardation force. We can find out the value of F and also the value of A. How can we solve it? We know from the laws of equation V equal to U V square equal to U square plus 2AS. Now V equal to 0, M equal to 20 gram. Therefore, M equal to 20 gram convert in Newton SI unit, that is 20 divided by 1000 kg, that is it is 0.02 kg. U equal to 350 meter second inverse and V equal to 0, S equal to 40 semi, 40 divided by 100 meter, that is 0.4 meter. Put all this value in this. V square equal to U square. We can see it V square equal to U square minus 2AS, because here A is minus. As the body comes to rest, A becomes minus A. So the equation is minus. When the final velocity is less than the initial velocity, that is retardation occur, then we can use negative sign in spite of positive sign. Therefore, 2 into A into S 0.4. From this we can get A equal to 350 square divided by 2 into 0.4. If we put it in calculator, we can get the value of A is 1.53 into 10 to the power 5. We can get A is 1.53 into 10 to the power 5 meter second. Then what is the retardation force? We find out the value of A. Then what is the retardation force? F equal to M times A. We can know M equal to 0.02 into 1.53 into 10 to the power 5 as in SI unit, so Newton. We can get it as 3062.5 Newton. So in this way we can solve any numericals. At first we use any of these motional equation, we can write it S equal to Vt, V equal to U plus At, and then finding out the A, we can solve the numericals. A force of 10 kgf, next, a force of a force of 10 kgf is applied for 0.1 second on a body of mass 100 gram initially at rest. 10 kgf is applied on a body of mass 100 gram for 0.1 second initially at rest. Calculate, we have to find out the momentum, P, momentum acquired by the body, and the distance travelled by body in 0.1 second. Momentum and distance travelled by the body. How can we find out this? That is momentum P and distance S. We can know that P equal to mv. Initially at rest means U equal to 0. Initial velocity U equal to 0, and we don't know the final velocity V. Which we know? Force F. We can only know the force F equal to 10 kgf, that is 10 into 9.8 Newton, that is 98 Newton. We know mass m equal to 100 gram, that is 100 by 1000 0.1 kg, 0.1 kg, and we can know T equal to 0.1 s. Now we F equal to m a. Now what about a? A equal to, what is a? Now a equal to v minus u by t. So F equal to 98 m 0.1 into v minus 0 divided by t means 0.1. We can find out the value of v equal to 98 into 0.1. This 0.1 and this 0.1 is cancelled. So we can get v equal to 98 meter second inverse. We get v equal to 98 meter per second. Therefore, we can get mv, m is 0.1 into 98, 0.1 into 98, the unit is kilogram meter second inverse, that is 9.8 kilogram meter second inverse. If G is taken as 10, then we can get the value of P equal to 10 kilogram meter per second. If G is taken as 10, that is F equal to 9.8, in the place of 9.8 we can put 10, but if not mentioned, put it 10. And what is the total distance? We can know that, we can easily find out the distance. S equal to initially as rest, that is ut plus half a t square. U is 0, that is ut, the terms ut becomes 0 plus half a t square, a into t square. What is the value of a? We can know, we can get F equal to ma equation, a equal to F by m. The value of F is, we get 98 Newton, by m is, we can get 0.1. Therefore, 98 by 0.1, that is 980 meter second, minus 2. That is half into 980 into 0.1 square. We can value, we can, if we solve it in calculator, we can get 4.9 meter. If G will be taken as 10, then it will be 5 meter. In this way, we can solve any numericals of force. The next class, we can tell about momentum and couple of momentum, momentum force, equilibrium, static, dynamic equilibrium. So if you like this, please subscribe my channel and please tell me in comment that which chapter you need to learn or do numericals, or you feel don't feel understand easily. I can try it my level best to understand you. Thank you.